we're going to be talking about object composition, and we're also going to be talking about separating class specification, implementation, and client code. Okay, those are going to be the couple of topics for the day. We are going to be looking at and using a rectangle class. And here's a partial class diagram. This is actually, well, let me just talk about this. This particular class diagram is in your PowerPoints from this chapter. And it talks about object composition. Okay? Object composition is when you actually use an object within another object. So if you look at this class diagram, please tell me what's the class that we're looking at here. Carpet is the class, correct. Now inside the carpet, what instance fields do I have? I have price per square yard, I have size, and I also have another class inside of it, so a rectangle. And so basically what they're saying here is that I have a rectangle composed inside of a carpet, or a carpet is composed of a rectangle, is basically what they're saying, okay? And so when you use another class within a class, that's called composition. You can kind of think of it in terms of math when you have like a function call, like f of g of x, when you have a function within a function, okay? You're composing those functions. We are only going to look at one particular function today, or excuse me, class, and that's going to be the rectangle class. And we are going to use the pre-written code for the rectangle class that is in your textbook. And it happens to be, I think this is program 7-11 from your textbook. I'm going to take this code and we're going to throw it into Visual Studio. In Visual Studio, remember, when you go to create a new project, you do File, New Project. And you guys are welcome to do this along with me, or it might be the best just to watch, and then you can come back to the video as necessary. The reason I'm starting from scratch is I do want to just double check on the settings that this is setting up, and we know it's loading slow, which is why it took so long to load earlier. We'll see if it loads. But what you see in front of you is not exactly the rectangle class. It looks close to it. Look at what's on the screen right now. Does that kind of look like what the rectangle class might be? What's a rectangle made up of? You got length and width, and they have their setter methods. For every instance field in a class, you should have setter methods. And then you have getter methods. And then this one has a method called getArea. But again, look at this closely. Is it finished? No. These really are only what? They're your prototypes. They're just the prototypes for the rectangle class, okay? And so you're going to learn how to do this today, because this is actually how you should design objects in a programming language such as C++, and the way that they are often implemented in the workplace, okay? So we are going to be creating a project, and it's just going to be a rectangle demo. And the goal is going to be that you guys are going to then do this with your class that you designed this week, okay? I'm going to create a empty project in Visual C++. And we always, when we choose an empty project, depending on how quickly our compiler works, we're going to learn how to write this code that's behind the scenes there, okay? What's going to happen is the class that you guys were told to create earlier this week, you put all the code into one file, okay? That is not typical, okay? You normally create separate files for each of your .cpp class files. So if you have a rectangle class, you have a .cpp for it. If you have a carpet class, you have a .cpp for it. On top of that, you also have a header file for each of them. So if I have a rectangle class, I have a .cpp and I have a .h file, okay? When you guys are adding things in your programs right now, oftentimes you guys will have at the top of your program a pound include statement. So if I look at this program 711, it has pound include IO stream. What does that pound include statement do? it copies in all of the code that you need to work, in this case, with the input-output stream, which is your C in, C outs, okay? We're going to learn how to write our own pound include directives up here for how to create and use different classes. And we're going to do that with the rectangle class, all right? I am going to select all of this and copy it because we are going to actually borrow it here in just a minute. Hopefully, if my Visual Studio comes up. You don't necessarily want to, we're going to put everything in one file to start with, and so you don't necessarily want to do that because you want to kind of protect your trade secrets, so to speak, with. And so when you sell things, for example, with coding, a lot of times you're going to sell a file, and in this case you might just sell the header file that tells the people how to interact with your program. And then you write the code behind the scenes and you don't let them see that because you don't want them to know how efficiently your code is working or how crappy your code might be, okay? It can go both ways, okay? And so we are going to be working here. I'm going to just call this the rectangle driver for right now. And it's going to be a .cpp file. And so what I'm going to be showing you is how do you take code, such as the rectangle class, and how do you separate it out into what we call implementation files, okay? This particular program has more than just the rectangle class in it. It has the rectangle class and it has the carpet class because it's doing the composition, okay? And if you look, it has that the price per square yard was a double and the size was a rectangle. I'm not actually going to be doing the carpet class. I'll probably delete it out here in a minute, but what I want you to do is focus on the rectangle class. We are going to create multiple files over here on the right hand side, and then I'm just going to be using this class right here to be my driver. And so basically I'm going to gut all of this. I'm going to take my rectangle definition and I'm probably going to delete the carpet definition and get rid of it because I really don't want people to have access to it because then they can see my code, so to speak. All right? In order to do that, we have to create two files. All right? One of them is your header file. And so when you do header files, you right click, you add a new item, and you choose, instead of a .cpp, you choose a .h. The header file has to be named exactly the same as the class that you're going to work with. And I'm going to be working with a rectangle class, so I'm going to name it rectangle, and it's going to put in the .h for me on the end. So if I look over here, I have rectangle.h. On my source files, I'm going to add a new item also, but now that's going to be a .cpp, and that's going to be rectangle.cpp. So you're going to take and separate out your class definition in a .cpp and your header files in separate files, okay? The textbook has already done this for us. This is the program that's in your textbook, so you should be reading your textbook and be a little bit familiar with this. The header file looks like this, and I am literally just copying what's from the textbook. It's called rectangle.h, and we're going to put it into our program here. But I'm going to talk you through what it means, okay, and why you have to use what you have here. First of all, you have these funky little lines at the top, and I just closed that, didn't mean to. This first statement here is a pound IFNDEF, and it stands for the following. It stands for if not defined, okay? And so that pound IFNDEF stands for if not defined, and what it's saying is if we haven't defined the rectangle, then go ahead and do what? Define it. You have to use, there's another way to do this, but for today you have to use pound if and def, and then all capitals is the standard, name of the class, underscore H, because it's the header file. And then you say, okay, if it's not defined, then define it. So it's like an if-else statement, okay? Way at the bottom of your code, you have a line that says pound end if. That's the end of that if statement. And so what happens is, if it's not defined, it's going to do all of this. If it is already defined, then it's going to skip it and go to the end if, all right? Ignore the pragma once for right now. And how do you write a header file? Your header file is basically your class diagram. If you look at this, it should mimic your class diagram. Do you have your private instance fields? Yes. Do you have your public fields? Yes. I have set length, set width, get length, get width, and get area. It does not have the constructor here. We may or may not need to add that. Okay, we'll talk about that in just a little bit. Okay. But what you're doing here, and somebody else already mentioned it, is basically all of these lines are your prototypes. Yes? Yep, Ben did. Okay. Those are your prototypes. What does the prototype and or what does the class diagram tell you about the methods in your classes? It tells you how to interact with them. Okay. How many things do you have to send in to set length? And what does it return? Okay, so in this particular one, it's actually returning whether it, a true or false on the fact that it's been set, apparently. Okay, I haven't looked at the code. All right, we might change that here in a little bit. What do your getters do? Your getters don't accept any values, but what do they return? They return a double. Okay, so what this is a template. If you were the person using this program, this is all you should need to know, is how to interact with it. It's kind of like the square root button on your calculator. Do you know how it works? Meaning, do you know what to type in to get it to work? You know how to interface with it, okay? Do you know what happens behind the scenes in your calculator? No. That's called the implementation, okay? So now what we're going to do is we're going to take, and the implementation for the rectangle class goes in a separate file called .cpp. Again, I am just copying from our textbook and what they have, and then I'm going to go back and I'm going to talk you through it, okay? So I'm going to copy this code into our project, and it goes in the rectangle.cpp file, and then we're going to pick it apart and look at it. So the first thing that you have to do, and if you haven't started doing this at the beginning of your programs, please give me at least a little comment about what that class does, okay? So this is the rectangle.cpp, and it's the implementation file for the rectangle class. What that means is it's got the guts of all the code. An implementation file is where your actual code goes, okay? So for you guys, and or like when you're writing your classes just a few minutes ago, if we take a look at this code, you guys were writing your setters, something like this, and you were writing your getters, or you just return a value. This right here is the guts of the code. Length assigned LAN, width assigned WID, return length. Okay, that's your trade secrets. Okay, these aren't real glorious right now, not yet. Okay, but that's your trade secrets. You don't want them to see how you're doing that, so you want to hide it. You hide that in an implementation file. What's the name of your implementation file? Name of this class .cpp. You also have to tell it how to connect with the other stuff, okay? And how do you get it to connect? There are a couple of different ways, or a couple of different things that you have to do. First of all, you have to have a pound include rectangle.h. My microphone is sounding really scratchy. Is it bugging you guys? Are you okay without the microphone? All right, we're just going to go with that. So pound include quote rectangle.h. What that's telling it to do is to copy in everything from the prototype files, from your header file. So you have to have that as your first line, okay? You don't have to have all of these comments, but it's depending on where you might work, they may require them or they will say don't use them. Okay, that's really totally dependent upon where you end up working down the road, okay? But you have to do the following. You have to use the return type, and now we can look at their code secrets, and now we'll know why they said it was a Boolean. What are they doing? They're not only getting the length, but they're also doing a data validation, okay? So they're just making sure that the length that is sent in is positive or 0. If it's not, then they're going to throw back a false or a statement that says, I can't use that data, please give me new data, okay, or something like that. So they're doing both a validation and if it is valid, what do? Then they assign length, your class level variable, to LAN, okay? More importantly, I need you to look at the header line, okay? Look at the header. Remember, the header is the very first line in a C++ function. Return type, name of the class that you need to associate with this method. You have to put the name of the class followed by these 2 colons, all right? Those 2 colons are called a scope resolution operator. Okay? Now just think about the name of that for a second. What does scope mean in programming? Scope is where the variables are declared, where your access is. So you're basically telling it where to find that method. Where are you going to find the set length method? Within the rectangles, within the scope of the rectangle class. And so that's why it's called a scope resolution operator. Okay? And then what follows is the name of the class, the name of the method, and then your data type, and however your method is written. Okay, the rest of your method follows. So basically, you guys are going to copy the class that you've already written, and then you're going to have to add your scope resolution operators to every single method. Okay, that's one thing you're going to have to do. If we take a look at the rectangle class, there's a set length, there's a set width. It also does data validation. There's a get length, get width. They all should look familiar to you from what you guys have been doing. Your getters simply return the values that were sent in. The getters simply return the class level values for those variables. Okay, nothing was sent in. And then get area is just length times width. Okay, do you remember why we don't have a area variable for one of my private instance fields? Do you guys remember why I don't say double area here? Right, you don't want to have stale data, okay? If you change the length or you change the width of the rectangle, the area would no longer be correct. So you never want to have stale data, so we don't put it there, all right? So you're going to be taking the class that you designed, you're going to be creating a header file, and you're going to be creating an implementation file, and it's going to look very similar to this. This code is available to you via your sample code in your textbooks in Chapter 7. I will also post it on course sites under implementation file, okay, so that you guys know. But the programs are, just so you know, program 711, and then it looks like 712, and then the other ones are, they're at the bottom of the folder. If you guys actually go to the folder, I can show you, maybe, if my computer's not too slow. So rectangle H and rectangle CPP are at the bottom of the folder, and then the other two programs are 11 and 12, okay? Now, we also need to have a driver, okay? I had copied over the carpet class, but I really just wanted to use the driver that works with rectangle, and so I think that's program 712, okay? Ben, stop talking, you're distracting me. And now you're on video. I am going to replace this driver, select all, and paste, Control V, and I'm going to put in my system pause. That's just strictly because of I'm working in this environment, and I could do Control F5 and I wouldn't have to use system pause, but I often just hit F5. And so I'm going to hit F5. It might take a while to compile, and we're going to see. But now look at how you declare the rectangle object. Whatever your object is, you have to use that class level name, the abstract data type, rectangle, or whatever your class is. Some of you did widget, some of you did a car, some of you did an inventory, etc. And then you're creating a box for the rectangle, and then they're going to calculate the area of a rectangle. Notice they're using a set box length right here. What did that return? What did set box length return? Do you remember? It returned a Boolean. So now they're saying if it's not true, then we're going to say it's invalid. All right. So based upon what gets sent back, it's going to say, and so it's not actually going to have them re-enter the data. Okay. They're just going to say, sorry, that data is invalid. If it passes setting the length and setting the width appropriately, then we're going to go ahead and get the length, get the width in, and print out the area, okay? And I am still waiting for it to load. So your driver should be the same driver that you guys, it's going to be everything that's inside what in your programs? Main. It's going to be your main. So your driver is basically just going to be your main. What you're going to have to remember though, and I didn't tell you this, right now I will tell you, in main, look at what else you have to include. Not only pound include IOStream, but you need to make sure you do pound include rectangle.h. So you have to include the header file so it knows where to get the definition for the rectangle. All right. So that rectangle.h in quotes will go in your driver, and rectangle.h in quotes will also go in your .cpp file. So you have to place that in your implementation file, and you have to place it in your driver file when you guys separate out your implementation. Okay. And we are maybe finally going to have some success. We'll see. Everything that is done here or being done here is also in the PowerPoints for this chapter under section 711. It's called Separating the Class, the Implementation, and the Client Code. What part is the client code, folks? The client code is your main. The client code is your driver, okay? You've got class specification, that's your .h. Class implementation is your .cpp of that class, and then the client code is the .cpp that has your main in it, okay? And so they talk you through right here. Class name.h, square.h is an example that they had. Place your member functions in a class in the implementation file. That's our .cpp file. And then you have to pound include the class specification file. That pound include rectangle.h that we did. I'm going to go over here and see if we have any success with running our rectangle program. So you want to look at, nope, it is still spinning its wheels. That is so depressing. Pound include guards. They talk here about that pound if and def. And it's just using, hey, look at that. This program, give me a length quickly. 59? I can't check that mentally. How about 6? Give me a width. 6. Does it check? There's the data. So it ran successfully, okay? So our execution is actually working. Yay! That took long enough. All right, so it talks here about the pound if and def. They call that the include guards. It's used to prevent a header file from being included twice. So remember, it's kind of like that if statement. If it's defined, then don't define it again, basically. And it talks about the fact that you want to use the underscore. It's usually the name of the header file in all capital letters, okay? So the capital letters, I honestly don't think it's required. That's just what they call an industry standard. So that's what I'm going to expect that you follow, okay? And then you have what should be done inside versus the inside versus the outside the class. The class should be designed to provide functions to store and retrieve data. And that's your input and output methods. That's your setters and your getters. All right. And that's all your textbook has for the PowerPoints on that section. So there's no way that you guys could have or probably would have understand that what you needed to do was to separate your files out into those 3 different places. So rectangle.h, rectangle.cpp, and then your driver. That was a very rough example of what you guys are going to need to do with your class. It explained a little bit about why you want to do that, and it's to kind of protect your data. It's also a way to help, I believe you can also use it to help do some debugging, and when you're working with accessing data files and stuff, you can also use the prototype in order to do some of that information gathering, okay? All right, I'm going to stop the video right now. Maybe. I don't know if I can get to where the stop is. Start closing some of these windows. Questions that you guys have? Yes. Do that, and I might actually try to, do a look. Yeah, that's all right. Yeah, go ahead. It kind of would, but I mean, just to work, and I was thinking about that later. I was like, yeah, that's kind of stale data, but with what they gave us, it's you can change it and just always call that get total cost method. And here's where my thinking was maybe partially wrong, because weren't we sending in values for that? And see, I've got to go back and read what the book said. But did the book say? Did the book say to send in 2 values? Because it just had that one comment at the bottom of it. So I mean, we have some flexibility to do what we think we need to have done. But see, since it's really using just the class level variables, we shouldn't need to send anything in. Because it's using the price per item, and it's using the total number of items, right? And both of those are class level variables. So we should be able to do what they did here with the get area on the rectangle. So I think you can redesign it so it's not stale data. Yeah, that's fine. That's 100% fine. I'm not, yeah. Okay? If you did not submit a class before you leave today, I might be emailing your parents. How have you submitted them so far? Submit your .cpp file, Ben. Okay? Connor, did you submit your class?
Yeah, I did.
Trey? Got a few hairs cut. Cool. Looking good. All right. You need to, do you have a class designed? Written?
Yeah.
Submit it. Second row there. Carson, Cooper? Is your class submitted? Okay. Top row. Is your class submitted? Everybody? Savi? Peter? Ben? Seth? Zach? Submit your class. Devin? Next Wednesday? About a half hour at least after school? No, next Wednesday. We'll have to look at our schedule, but you've got to be doing some work outside of class, okay? Caleb? Is yours in? Okay. Okay. Happy Friday.